to urbanization and climate change. I would also like to acknowledge my co-authors who are also my supervisors. Yeah, going into the background, so most of us here are familiar with the age-old classic definition of UHI. So it is essentially the temperature difference between an urban area and a rural reference location. Let's try to actually visualize this based on some real data for in the context of Melbourne. So let's say we take a transect across Melbourne, connecting two rural locations here. Um, and the transit would be around 100 kilometers, and we'll try to take a temperature profile and see what that may look like. So this is what the transit would look like when you overlay the urban fringes of Melbourne. The colored areas show the existing urban fringes of Melbourne. In terms of taking a temperature profile, we can actually take multiple temperature profiles at different time steps. But for simplicity, let's take temperature profiles at daily maximum temperature and daily minimum temperature, and see how that looks like. So this graph shows the top graph shows the temperature profile when you use Tmax, and the bottom one shows the temperature profile when you use Tmin. Um, from the onset, you can see that Tmin there's a clear warming trend here, coming up to the most built-up center of the city. The difference between the center of the city and the furthest rural location would be around 2 degrees Celsius if you look at the y-axis here. But if you look at the max value, which corresponds to daytime temperature, that increasing trend isn't as obvious. So here we can see the range also is around 1.2, 0.3 degrees Celsius. So although this seems like a little peak there, but it's not really considerable. So you can see that T mean actually shows a variation in temperatures because due to urbanization. So in terms of my objectives for this talk today, I want to kind of build up a comprehensive understanding of UHI across Australian capital cities. From the literature review that I did, I couldn't really find a comprehensive analysis looking at all Australian cities, but I could find different studies looking at different parts of Australia or different one or two cities using a few methods which are not like scalable to other locations as well. So further going on from this, I also want to understand how UHI behavior varies across different Australian climate zones. Here in Australia, we have different climate zones. It's a big country, so capital cities are scattered across different parts of the country as well. So building up from this, I also want to understand how UHI, the impacts of UHI has affected warming trends in Australian capital cities. So for this, we need to build up a consistent approach of actually analyzing long-term UHI trends using a consistent approach. So that's what I'll try to build up in the first half of my presentation. In terms of study locations, I picked six capital cities. So Melbourne and Sydney, which are the most urbanized capital cities in Australia. I also looked at Brisbane, Adelaide, Perth, which are comparable in terms of population as well. And I also picked the capital city in the Northern Territory, which is Darwin. Although Darwin is called a capital city, the population is around 35 times smaller than Melbourne, so it has a population of about 150,000, but it's still technically a capital city, and that's the main capital city we have in the tropical region of the country. So for each capital city, we picked one urban location and three rural reference locations. For example, in Melbourne, we have the urban location here. We pick three rural capital locations as such. The reason for picking multiple rural locations is to actually isolate the effects of geography specific effects such as the distance from the coast and things like elevation differences. So in terms of picking the urban rural pairs, we made sure we actually at least pick one location which is comparable from the coast, kind of neutralize the sea breeze effects, and we also made sure at least one of the locations is comparable in elevation to the urban location as well. So this is what it would again look like with respect to the urban fringe. So in terms of the study design, we had six capital cities, and each of these capital cities are located in a unique climate zone. So Sydney, Melbourne are technically in temperate climate zones. In Adelaide and Perth are in a Mediterranean climate zone. Um, Darwin is in a tropical climate zone. Um, if you go to Brisbane, it's subtropical, so it's halfway in between. These correspond to the Köppen climate zones for Australia as well. So using the four, so for each capital climate zone, I picked one representative capital city just to make things simplified for the initial part of the analysis. So using those four capital cities, started using weather station data from the Bureau of Meteorology here in Australia. So we looked at diurnal trends, looked at seasonal trends to see if there's any variation between the different cities. Going back to all six capital cities, we also started building a methodology to look at long-term warming trends in the cities. So for this, we use the Australian grid climate data product, also produced by the Bureau of Meteorology. So it's an observational product which is at a 5 kilometer grid resolution, which has been produced by the Bureau of Meteorology. The it uses observations to actually build up a long-term grid data observational grid data product for Australia. So the the data product is explained in detail in the paper by Jones et al. From the Bureau. If you, let's start going into the diurnal trends. Many of you might have already seen a similar plot. So let's just compare one urban location and one rural location and start looking at their temperature profiles. So on the x-axis you have the time of day starting from midnight all the way to night again. The temperatures are given in the y-axis here. This red line shows the red dash line shows the temperature profiles in the urban area, and the blue dash line shows the temperature profile in the rural area. So we can actually use the temperature difference between the two profiles to actually calculate the UHI intensity at each time step. So what we did was we calculated the UHI intensity, which is shown by this y-axis on the far left-hand corner. So here we could see that the UHI intensity, the peak value of the UHI intensity is observed during nighttime, and the lowest UHI is observed during daytime. This is the key inference we got from this plot. So peak UHI is observed at night. Do we see the same pattern for all climate zones? See, indeed we do. For each climate zone, peak UHI is sort of during nighttime. So yeah, so the conclusion from these plots is that peak UHI is observed at night. So let's start looking at the seasonal trends here. In terms of seasonality, we plotted the UHI intensity for this urban-rural pair again. So the y-axis shows the time of day, the x-axis shows the time or the day categorized by months, but all of these values are for each day. And the color shows the UHI intensity. So the blue areas show areas of negative UHI, so which means rural areas are cooler than urban areas, and the dark red areas show areas where UHI intensity is positive. That is where urban areas are warmer than rural areas. So if you overlay the seasons relevant to Melbourne, this is what it looks like. So in Melbourne, we have winters in the middle of the year, similar to this time, and we have summer towards the end and the beginning of the year. So here we found out that the lowest UHI intensity is observed during daytime in summer. That's why as you see from these dark red spots here. The highest UHI is actually, the previous one I should say lowest UHI is during daytime in summer, the blue spot here, and the highest UHI is nighttime in summer. So the previous one I pointed out, these ones. And we also found out that UHI is mostly positive during winter, so there's not many negative UHI in winter. So we're kind of building up a theme here. So the key conclusion, the commonality here in this plot is positive UHI is consistently observed during nighttime. Um, so what does this look like for all capital cities? We started looking at the seasonality trends for all capital cities. Let's first overlay the seasons for each climate zone. So Melbourne, we also saw the pattern. If you look at Perth, which is the Mediterranean city out here, we have similarish seasons to that of Melbourne. So winters in the middle of the year and summers to the end and beginning of the year. So here we can see a pattern similar to that of Melbourne. So there's a seasonality pattern similar to summers and winters. Um, Again, the interesting part, if you go to Darwin, which is the northernmost capital city, it's a tropical city. The UHI intensity actually follows the tropical seasons. So we have dry seasons in the middle of the year. We have wet seasons towards January to December. So we found out that the maximum UHI intensity is observed during night time in the dry season. So if you go to Brisbane, which is up here, which is halfway between the tropical area and the temperate area, it is a subtropical city. So the patterns we see here is bit of a hybrid between Melbourne and Darwin. So in Brisbane, we get dry winters and we get wet summers. So here we see the maximum UHI intensity at night during the drier winters as well. Wet summers, not so much, but the most intense UHI is here. So I guess you all guess the commonality between all these plots, which is positive UHI is consistently observed during nighttime, regardless of the climate zone. So So now starting to build up onto the longer term trends, we need to find a representation of UHI for a long term analysis. So we noticed that the UHI effect due to urbanization can be quantified at night time. So there's a the signal of urbanization in at night time. So fortunate for us, we can actually use team in to start looking at the urban effects on the urban climate. So fortunately for us, the AGCD data product has long-term climate trends, team-in trends for over a century. So it has daily values of team-in and Tmax over a long period of time. So we can actually start using this to analyze the long-term climate trends. So here we are looking at the climate trends for Melbourne and its three rural locations. In terms of the climate trends, Melbourne has been warming at a rate of 0.57 degrees Celsius per decade over the past 60 years. If you look at the rural reference locations, they haven't been warming as much in terms of the values. So if we quantify the average warming values over the past 60 years, Melbourne has warmed by around 0.94 degrees Celsius, whereas the other rural locations haven't warmed as much. Um, so the key conclusion here: the city has experienced more nighttime warming, in addition to the fact that the city has been warmer. If you start to summarize these values for all locations in Australia, we'll first start for Melbourne. So I tried to summarize these values in a table here. The first column shows the location, second column shows the average T mean value over the past 6 years, and the third column shows the T mean trend over the past 6 years as well. Yeah, Melbourne, we saw this the urban area is warmer, and the city has been warming at a faster rate. If you go to city, which is a slightly bigger city than Melbourne, we also see that the city is warmer than the rural reference locations comparatively, and we also see that Sydney has been warming at a faster rate than all locations in Melbourne, and the urban area has been warming at a faster rate than the rural locations as well. If you go to Brisbane, we see similar trends, but the warming trend isn't as large as the ones in Sydney and Melbourne. So, some comparatively smaller warming trend. However, there is a warming trend here. If you look at the smaller city of Darwin, it was surprising to find there wasn't a significant warming trend observed in Darwin. Um, if we go to Perth here, we saw significant warming trends in the urban location and one rural location. The differences weren't that different. The differences in warming trends weren't so different, but two locations weren't warming at a significant rate. If you look at Adelaide, again, cities are warmer. There's a considerable warming rate inside the city centre as well. So key conclusions here: cities are already warm at night, but there is also a signal that the bigger cities have experienced more nighttime warming. So that is significant, I think. In terms of the final thoughts, we found out that UHI can be quantified using the T-mean indicator. So so this provides a good compromise in terms of using daily temperature from the data products. If you use like a weather station data, do all of these weather stations come and go. There's different availabilities in weather stations over the period. So this consistent data product provided by the bureau is actually helps us to assess these kinds of patterns. We also found out in terms of seasonality, high UHI during winter, high UHI during the dry season. We also saw that there's a noticeable signal of climate change indicating a nighttime warming trend, where cities are already warmer than surrounding areas at night, but cities are also warming at a faster rate. So could this be a signal of like increasing urbanization over the past 60 or so years? It's a good question to ask. Yeah, with that question, I'll close my presentation and happy to take any questions.
Thanks, Vihan. Oh, lots of questions.
Yeah. First, first to ask. Far back. First to ask. Yeah.
Thank you. It was a wonderful presentation.
Thank you.
I just wanted to ask, how does your study compare to other cities in the world? I can see there are many similarities, but did you find any difference from the already existing literature? And how does it add? Like, what are the differences from other cities?
Yeah, for in terms of the novelty of this research, there wasn't a comparative study like this for Australia for all Australian capacities. There were studies looking at it in different angles for different Australian capacities. But I'm trying to develop a more robust way of doing it for all Australian capacities, which can be used for long-term analysis. In terms of looking at other capital cities, I think that I've seen that bigger cities. I saw an old paper in New York where the bigger cities have actually warmed. Like in terms of nighttime warming, there is a this is a common
This is
feature.
common across.
Yeah,
So, is
common.
there any difference in Australian cities?
No, the bigger cities have been warmer at faster rate. Yeah, no difference really. Yeah, so it adds to the message that cities have been warming at faster as well. Yeah,
Thank you.
thanks.
Yeah, thank you for the presentation. I just want to know why you focus so much on minimum temperature. If you eventually want to look at climate change, I think you will have to go for average temperature, because what we observe in the UK is that actually rural sites increase in temperature much more rapidly. And indeed, I think you finally made a good point in your conclusion that this you have eventually to control for urbanization that is happening like next to the sites, your urban sites. Because otherwise, and still then you see that your standard deviation is still basically you say that the cities are going fast at faster rate, but you're always falling within standard deviation of the rural sites too. I think reaching this conclusion currently is a bit like, well, I mean, I don't think it's super strong as a case. So you probably need to control for other factors there before reaching the conclusion.
Yeah. In terms of your questions, I think I can break it down into a couple of questions. First of all, using T-min, the rationale for, I guess, justifying T-min would be when you look at heat waves. Yeah, daytime it will be higher, but at nighttime the temperature won't go down as fast, and it's still rural areas will stay warmer persistently during nighttime. So that will actually exacerbate the impacts of heat waves. So that's the significance of you considering T-min as well in long-term trends. We did also look at Tmax and T average. Tmax, we found out there isn't a significant difference between urban and rural locations. All locations have warmed pretty much at a similar rate. So when you get a T average, it kind of neutralizes the two. And sometimes there are significant differences, but sometimes they're not. But here I'm trying to actually quantify the impacts of urbanization and what impacts that has on the urban energy balance. Um,
But how can you reach values of like -8 urban thermal intensity then at certain hours of the day when you have your plots that are your kind of red and blue plots?
yeah.
If you say that you don't have a very high difference in maximum temperature, how do you reach such high value?
At nighttime?
Surprised me, yeah.
At nighttime, so that happens with the urban energy.
It's at evening. It's like daytime. Negative urban heat and intensity.
Yep, so that happens during daytime. Few key processes happening here. I can talk to you more after the presentation, but essentially summarizing it, it's when there's sunlight, sunlight overpowers pretty much everything. The urban effects, urban areas, rural areas will have sensible heat that's consistent throughout the areas. But during the day, urban areas actually start absorbing more energy and store that as kind of act like batteries and store the heat. But at night, when rural areas cool down much faster, urban areas still have energy stored up, which gets released overnight. So urban areas tend to stay warmer in terms of rural. So that's why the diurnal trends kind of show as well. Hope that's that.
Yeah, that makes sense. And I'm just saying, you say that the maximum temperature is similar, however, your plot is just saying a completely different thing. And I'm a bit surprised by that. So I was just wondering how you eventually measure the intensities of those plots.
It's just a temperature difference between urban minus rural. So I'm just comparing two stations here, two stations for each location. So looking, it's just getting at each time step. So we have 30-minute data. So each time step we just calculate urban temperature minus rural temperature. So that will give either a positive value or negative value. That makes sense.
Yeah, it does. Okay, we can discuss that.
Yeah, we can discuss more. Thank you.
Thanks, Vihan.
Thanks for the question.
Next up, we have Valentijn.